Okay, now we move on to the graphical analysis. Okay, we still use the same Stata data file as the one we used yesterday, file number 3. I think the first question will be the easiest. We have the real earnings, but we want to generate log earnings. Okay, but let's have Stata file number 3. It is open, so let's do the first command, which is the easiest. Generate log earnings 1 equal the log of earnings 1. Okay, and then let's do a box plot. Over race. Later I'm going to explain the difference between over race, over gender, and by race or by gender. You are going to see some difference for the graphical sketch. So let's start with the first one. So it's no longer statistical analysis, but rather graphical analysis. So let's click graphics, box plot. I don't think you can do it with Excel. Which variable? Log earnings 1. Categories, it means over actually, over race. Okay, and you see this thing popping up, it means in progress. It takes a bit of time to generate the box plot. Okay, it is okay, and then later I will explain to you how you can save the chart and then as picture or even as PDF files actually, and then you can copy and paste onto your research paper. Okay, so this is exactly the same one, and then I think this line stands for the median. I think this one stands for the 25th percentile if I remember correctly, and this other horizontal line above the median stands for the 75th percentile if I remember correctly. Okay, and then these dots stands for the outliers actually. But if you look at the box plot result, it gives you a message that the white population, they earn the highest, let's say on average or in median terms, followed by the Indian population. Okay, next one, it is the same question, but this time I impose the restriction. In other words, the if command only include working age population. Let's close this box plot. Go back to graphics, box plot. Again, just like the statistical tables, in the graph box window, it still stores the most recently done command. This is why you still see log earnings here, over race. But I think the if restrictions, I need to type between 15 and 65 years old. Okay. Okay, I don't think the box plot would look much different actually, quite similar to the previous one. Okay, yeah, it is more or less the same. Next one, box plot, but instead of the over command, rather we opt for by race, and I'm going to show you if you use the by option, the box plot looks very ugly. It's hard to compare the four racial box plot, but let's do it once, okay, from a learning perspective. So graphics, box plot, but the by option actually works quite well for the pie chart, which we are going to do later. We untick this because according to the command, it is no longer over race, but rather by race. So we have to go for this one, by race. And does the working age population restriction still applicable? It is. So let's leave this unchanged, but by race. And you are going to see a very ugly result. Okay, it is indeed very ugly. Okay. Next one, let's do an XY scatter plot. Remember from the question yesterday, we derived the correlation coefficient between age and real earnings, positive 0.1 something, but not a particularly strong relationship. This is why the box plot we are going to generate would not really show a strong positive relationship. But let's do the XY scatter plot. Graphics, two-way graph. You already see the keyword scatter. Create, scatter, y variable is log earnings 1, x variable age. Okay, There are some plastic surgery skills like changing the color and the size of the dot, but I will leave it until the very end. These plastic surgery skills, okay. Accept, okay. Okay. Next one. Pie chart, you want to derive the ratio composition. For the pie chart, the by command would work well, but let's start with the basics. Graphics, pie chart, category variable, it is the ratio composition. Okay. Okay, clearly you can see the African share is most dominant, almost 3/4. And then this one, this is what I meant by the fact that the by command would work pretty well for pie chart. So in other words, you want to derive the ratio composition by gender. So in other words, there will be 2 pie charts. Okay, so let's do that. Graphics, pie chart. Still the ratio composition, but by gender. Okay. So you can see the ratio composition is more or less the same across both genders. It's the African share being most dominant, almost 3/4. Okay. Next one, this is called the bar chart. This is vertical bar chart. I want to derive the mean log real earnings over race. So graphics, bar chart. I want to derive the mean. You see, Stata is quite smart already, making the right suggestion. The mean of what? You need to specify the variable. Log earnings 1. Vertical bar chart. Later, I will show you how to do a horizontal bar chart. It's more or less the same command, except you will see the bars shown horizontally. Over, is it over race? Let me go back to the question. Yes, over race. Okay. Is there a restriction on working age population? Not in this case, so okay. Okay, so you can see on average, the log real earnings is the highest for the white population group. Okay. And then let's move on to the next question. The by command, again, just like the box plot, the by command would give you very disappointing or very ugly result. It's hard to interpret, but let's just do this question once, just for the sake of learning the command. Bar chart, yeah, mean log earnings, but instead of over race, so untick this box, rather we do it by race. Okay. A very horrible outcome, yeah, indeed. Okay. Next one. We want to derive the same bar chart, but first over race, then over gender. In other words, there will be 8 bars in total. Over race, over gender. 4 times 2, so 8 bars in total. So let's do this one. Graphics, bar chart. Let's untick the by option. But go back to categories, it means over. First over race, then over gender. Okay, over race, over gender. Still the same stats, mean of log earnings 1. So it shows that on average, the log real mean earnings is the highest, I think, for the male white population group. Okay. Okay. And then, okay, this is the interesting one, histogram. Okay, let's look at the question. Histogram for the age variable. The width of each interval would be 10 years, so you see the categories, 10 to 19, 20 to 29, so forth. So in other words, the question implies we only want to include people aged from 10 years old to 69 years old. And then for the y-axis, I want to show the percentage of people in each age interval from 10 to 69 only. Okay, first of all, I need to check if age is a continuous or discrete variable. If it is a discrete variable, it means age is round off in integers, maybe 5 years, 10 years, but no decimals involved. But if age involves decimals, it is a continuous variable. So based on the information in the data spreadsheet, it is a discrete variable. Okay, no decimals involved. because we have to answer this question, okay, we need to specify whether it is a discrete or continuous variable. So graphics, histogram, the data is discrete, age, you must specify the y-axis, I want to show the percentage. Width of the bin or the interval 10, minimum value is 10. I think I should specify age is between 10 to 69. I think these are the people we want to include. Okay, and then the density plot, I want to include the normal distribution line chart. Okay, so take this one. I think I can take OK now. Let me show you one more time. People age 10 to 69. Density plot, take this one. I want to include the normal distribution curve. Age, discrete. Y-axis show the percent. The width of each interval, 10 years. Okay, so this is the outcome. Does it really look like a normal distribution? I am not sure. Okay. Next one. Same one, histogram. Is it the same question? Oh, actually, I have done 5.5.2. I added the normal distribution curve. Okay. So I think I can move on to the next one. Log real earnings. I think for the log real earnings, it definitely involves decimal. So it is a continuous variable. And then from 4 up to all the way, no specification on the maximum value as long as it is at least 4. And then again, we add the normal distribution line. So graphics, histogram. This time it is a continuous variable. Log earnings 1%, width is 1, lower limit is 4, and then I don't think I need to specify anything here, so I delete everything. Density plot, leave it ticked. Okay, log earnings, continuous, percent, width of the interval is 1, lower limit is 4, or the minimum value is 4. Okay, so this is how the histogram looks like. Okay, then we can do a revision exercise. Let's see how many questions we can do. This one, still the same data set, box plot, log earnings over race and over gender. So graphics, box plot, log earnings here, over race, over gender. I just want to make sure there's nothing. Okay, I must untick this one. If restriction, okay, it's not about working age population, I must delete everything here. Let's check one more time. Over race and over gender. Okay. Okay, box plot. Is it on, yeah, one variable. Okay. Okay. So again, it shows the white population seems to have earned more on average, male white and female whites. Okay, but see the wider range here for the African population. This is why in some labor economics literature it talks about within African inequality in earnings has worsened over the years. Okay, next one, pie chart. This time on gender composition by race. So there will be 4 pie charts in the same figure. So let's go to graphics, pie chart. This time I want gender composition, but by race. By race, gender composition. I don't think there's any if restriction according to the questions. So this is the answer. Okay. So it seems the male share is most dominant for the Indian population group. You can clearly see this portion is much greater for the Indian population compared with the other 3 pie charts. Okay, last one before we take a break. Okay, graphics, bar chart, over gender. and overlays. Okay,